Hello, my name is Junadi Lauris, and today I want to demonstrate UiPath agentic orchestration capability for processing work orders in a mining context. While this may seem like an industry-specific use case at first, work order processing is a universal challenge across manufacturing, transportation, utilities, and even healthcare. Now, in the mining and natural resources industry, every minute of downtime costs thousands, sometimes millions of dollars. When critical machinery breaks down, there are usually no spares available. A 400-ton iron ore truck, for instance, which you simply cannot replace on the spot. This forces companies to fix the equipment as quickly as possible. Traditional work order processing is slow, manual, and inefficient, often leading to extended downtime. This is where agents and agentic orchestration come in. By leveraging AI-powered agents, work order processing can be streamlined and automated to reduce downtime and optimize operational efficiency. While this work order process looks like a linear and simple flow, the reality is it's more like managing a series of complicated tasks. Let me give you an example. Finding the right technician isn't as simple as checking who's available. We need to go into the system to find someone with the right skill sets and certification. We then also need to consider where they're currently at, the proximity to the site of the repair, to minimize transportation costs. And we also want to ensure that they aren't committed to any critical project that may clash with our repair timeline. Now, managing all these moving parts is usually very slow and highly error-prone, as we can imagine. However, the complexity of these business rules is also why an agentic solution is fit for purpose here. While it may be hard to define rules for each of the tasks, describing it like what I just did in simple, natural language makes perfect sense. This is why agents thrive. Let's dive right into the demo. Here's an example of the kind of request that triggers a work order. In this case, it's a gearbox replacement on a truck with a specific equipment ID, and there is a brief problem statement in the requested work. As you can see, it's not immediately clear what skills and qualifications are required to complete the actual work. This needs to be manually identified by the coordinator, and you can imagine this is quite tedious and can have potential oversights. However, with access to contextual documents, such as, say, the instruction manuals for different types of equipment, or job descriptions for the technicians within the organizations, agents can use this to cross-check with the requested work and identify the right resources required. Next, let's take a look at the agentic orchestration workflow for this process. It's quite a straightforward process with a number of agents working together and in parallel. Specifically, there are 6 agents in total. It's designed to be small enough to focus on a specific goal in mind. When we kick this off, the first agent picks up the job of analyzing the work order emails from the mailbox. It tries to figure out 4 things from the email: the type of skill and roles required to carry out the repair job, what tools and parts are required, as well as site-specific safety requirements. These are then passed to each of the 4 agents running in parallel to perform their own tasks. Now, while this is running, let's take a look at our personal allocation agent in more details in Agent Builder. An agent is made of a few components. It's got its foundational model, a name, and general description. It has system and user prompts, which most of us are familiar with. They describe the agent's roles and responsibilities and its objective. Then there are tools, which define what actions an agent can take. This is quite powerful. Here I've provided 2. One is to find a list of available workers, and another to get the mining locations. During the execution, the agent will plan and use these tools at its disposal to try and meet its goals. Having access to tools is one of UiPath agent's key differentiator. This enables the agent to be able to do more instead of just think. So, what are the available tools? We can use activities from our integration service connectors, typically via an API. We can also access a list of automation that has been built by your organizations and published into Orchestrator. And finally, we can also use other agents as tools. Next, we have context, which is what grounded an agent with a knowledge base. Without it, an agent is just a large language model. This is quite important. Finally, we have an escalation option via an app, which an agent can leverage when it cannot achieve its goal or when it needs human assistance. Now let's run this agent with example input to see it in action. The agent has recommended Lucas as the maintenance supervisor because of this reason. Let's get back to our agentic orchestration to see the end-to-end automation. The workflow is completed successfully here. You can see when all the 4 agents has completed their tasks, the output is being formatted into a human and readable output by our response agent. If required, we can get a person to review the email before it replies to the initial work order email. So, to recap, all the agents are task-oriented and modular, which promotes reusability. And think of a slight tweak to our personal agent, and we can use it to find appropriate shift casual worker in a completely different industry. In healthcare, for example, an urgent medical equipment that needs to be shipped immediately can also rely on variations of our tool agent. And here we can see the final response email. The list of people required has been highlighted, including when they can be available on site. The tools and parts that are missing has been highlighted, including those that require shipping and order from our supplier. And finally, all the safety requirements included. Thank you.